Okay, now we're going to talk about systems of equations. Okay, a system of equation by definition is one or more equations with one or more unknown, like this. Here's two equations, and each of them has an x and a y that are unknown. And this is an example of a system. We're only going to do two equations with two unknowns, but know that you could have three equations with more than two variables in it, but we're going to do this. Okay. So the solution to this system is where these lines intersect, because basically it's the only XY pair that's true in both of these. So if the XY ordered pair has to work in this one and it has to work in this one, then it's the place where they intersect on a graph. Okay, so let me show you how to figure that out. Here's my graph. And my first equation was y equals 1/3 x plus 1. So my y-intercept is 1 and my slope is 1/3. That's pretty easy. We just go to 1 on the y-axis. And then we go up 1 over 3. We can do it again, up 1 over 3. I could go down 1, left 3 to make sure I have it right also. I can connect those lines. There's my first graph. Now next I'm going to graph the other one, and where they meet is the answer. Okay, y equals negative 2x plus 4. I go to 4 on the y-axis, and then I go down 2 over 1, down 2 over 1. So 1, 2, 3, 4, down 2 over 1, down 2 over 1. Graph my graph. Now, I didn't draw that second line perfectly straight. I got a little bit wiggly in here, but that's okay. Look at where they intersect. See where they intersect? It's not on a whole number. It's like in between boxes. I can't really tell what it is. It sort of looks like it's over maybe 1.5, up 1.5. I can't really tell exactly where that point is, because even though graphing is a method, that's definitely a method for solving, it's not a very effective method, because first of all, who's going to be carrying around a graph board with them all the time? Not me. I wanted to just do this on a regular whiteboard, but my lines wouldn't have been straight enough to tell anyway, even if it did meet at a whole number value. But even when I use a graph board, it's not precise enough to be able to tell. So graphing is a good way to like check your answers, to get an idea, like, is this kind of close? But really, it's not a very good method. So let me show you a better method for solving. Okay. I'll tell you, by the way, that I already know what this answer actually was. And this answer actually ended up being, let's see, I had it, I figured it out. It ends up being 1 1/7 and 1 3/7. Well, I'm not going to prove to you that that's that, because I'm going to show you how to do other ones, but no wonder why that was hard to tell. It was a little over 1, but we couldn't really tell exactly what it was. And therefore, I'm going to show you a different way to solve these, okay? Let me give you a different system, though. We'll come back to that one, maybe not. There's lots of different systems I can use. So here's another system of equations. I'm going to do y equals 2x plus 1 and 2x plus 4y equals 24. Okay, now, I wouldn't want to graph this one anyway, because in order to graph it, I would have to put this into y equals mx plus b form, or I could find my x and y intercepts, which we know how to do. We could cover that up and say our y-intercept is at 6, because when I solve that, I get 6. So my y-intercept is 0, 6, and my x-intercept is 24 divided by 2 is 12. So my x-intercept is 12, 0. And this one I could easily graph. May or may not meet in a nice point. We don't know. But it's going to be off the graph, because 24 divided by 2 is 12, and 12 is way bigger than I want to put on a little graph like this. So let's do another way. And what we're going to do is called substitution. Now, substitution is best used. You can use it in any way, any system, but it's best used when one of the systems already is solved in terms of another variable. That means that one of the equations has a variable by itself. In this problem, y is by itself. In this one, I do not have a variable by itself. But if one or both of the equations has a variable by itself, then the best method to use is substitution. And here's how you do it. You take the value, excuse me for a second, I want to grab a different color marker. And I had dropped it on the floor. Okay, you're going to take the value of y, which is 2x plus 1, and substitute it into this equation where y is. Now, this is very much like doing a composite function because you're putting one function into another function. So basically, that is what you're doing. You're going to take your 2x plus 1, and you're going to replace it right there. All right? Substitution. So I'm going to go, my new equation has 2x plus 4y equals 24, becomes 2x plus 4, but instead of writing y, I'm going to write 2x plus 1, and then equals 24. So this is the substitution. I started with 2x plus 4 times the y value is 2x plus 1 equals 24. Distribute and combine like terms. I get 2x plus 8x plus 4 equals 24. I combine like terms. I get 10x equals 20. I distributed 4x plus 8x plus 4. Then I combine my terms, like terms got 10. I subtracted 4 and got 20. And then I get x equals 20 divided by 10 is 2. So I know my x value is 2. And then I can go ahead and plug that 2 into here, because now x is 2, and I can find out my y value. So 2 times 2 is 4, plus 1 is 5. So 2, 5 should be my answer. And I'm just going to check that out. First, I need to make sure it works in both, and then I am going to actually graph it to show you that it works if you graph it and it's a whole number. So we've got 2 goes in here, or 2 goes in here. 2 times 2 is 4, plus 4 times 5 is 20. 4 plus 20 is 24. It definitely worked in here. 2 times 2 is 4, plus 1 is 5. It definitely worked in here. They're both right. Now, the next thing I'm going to do is I'm going to rearrange my y equals mx plus b for the second equation. I get 4y equals negative 2x plus 12. Then I get y equals negative 2/4 x plus 3. When I know I skipped a bunch of steps here, but this is something that you have done before. I moved my x over here. It became negative. Then I divided everything by 4. I got negative 2/4 x plus 3. I reduced that to y equals negative 1/2 x plus 3. I go ahead and I graph these two just to prove that it worked. And you don't have to do this part, but I think it's always a good idea. Y equals 2x plus 1, up 2 over 1, up 2 over 1. Plus it helps you reinforce your graphing skills, which is also important. Then I get y equals negative 1/2 x plus 3. Go to 3. Go down 1 over 2, down 1 over 2. Draw my line. And hey, you can see that these are perpendicular because my slopes were 2 and negative 1/2. That's cool. We proved that before. And the intersecting point is at over 1 up 2. I thought the intersecting point was supposed to be 2, 5. Over 1 up 2. What happened? Down 1 over 2, down 1 over 2. 2x plus 1, up 2 over 1, up 2 over 1. I have to find my mistake. I do, because I need to show you guys it's normal to make mistakes, and that is also important to check your work. So I'm going to rearrange this one again. No, I'm going to use my y and x intercepts instead. When I replace x with 0, I get y is 6. When I replace y with 0, I get x is 12. So maybe I'll try using those points instead, because I can't find quickly what my mistake was for rearranging and showing you that these will meet at 2, 5. So I'm going to do it a different way. And you know what? I know this might seem a little unprofessional to just sit here and you guys watching me try to figure out a mistake, but it's real life. It's good. Up 1 and then up 2 over 1. and then down 2 over 1. Here is my y equals 2x plus 1. Now I'm going to do intercepts of 0, 6, and 12, 0. Over 0 up 6, 1, 2, 3, 4, 5, 6. And over 12 up 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to redraw this line. And I'm going to show you that it does meet at over 2 up 1, 2, 3, 4, 5, over 2 up 5. So it does work. They still are perpendicular. That was important that they were perpendicular because their slopes were 2 and negative 1/2. I still don't know where I made my mistake before. So if you want to go ahead and try to figure it out, email me and you can get some extra credit. ktoef@k12.com. Anyway, let me show you some more. Okay, so there is 1. Lasted a little while because I made a mistake, but that is okay. All right, next one, we are going to try negative 2x plus y equals negative 6, and y equals 2x plus 4. Okay, since one of these is solved in terms of a variable, then we are going to be doing substitution. Since y is by itself, I'm going to take this y value and replace it right there for y. So I end up with negative 2x plus, now my y value is 2x plus 4 equals negative 6. Now when I start solving, negative 2x and 2x actually cancel out, and I end up with something weird. Not like I did last time. I ended up with a weird statement like this, which is never true. 4 never equals negative 6. Well, that's because if this is, think about what the solution means. The solution is where they intersect. So if this is never true, that means they never intersect. And if they never intersect, that must mean that they are parallel. If they never intersect, there is no solution. No solution because they are parallel. Okay, let's check that one out. Let's turn this into y equals mx plus b. I won't make a mistake on that because it's easy. Move your 2x over here. You get y equals positive 2x minus 6. Y equals 2x minus 6 looks like this. Y equals 2x minus 6 starts at negative 6. 1, 2, 3, 4, 5, 6. Goes up 2 over 1, up 2 over 1. My next one was already in slope-intercept. It was y equals 2x plus 4. Y equals 2x plus 4. Start at 4. Go up 2 over 1, up 2 over 1. We already had seen that they had the same slope, so we knew they were going to be parallel, but just showing you these graphs are parallel. So if the solution to a system is where they meet and they never meet, then there's no solution. Okay, now what happens if you do this? What happens if you have something like this? Sorry. We're going to try y equals 4x minus 1 and negative 8x plus 2y equals negative 2. Okay, we're going to do substitution because this one is in terms of a variable. So we're going to replace 4x minus 1 right in here where y is. Okay, we're going to get negative 8x plus 2 times the y value of 4x minus 1 equals negative 2. Distribute and combine your like terms. Negative 8x plus 8x minus 2 equals negative 2 when I distributed. Now look at 8x, negative 8x and 8x are going to cancel out just like last time, but this time I end up with a statement that's true. Last time I ended up with a statement that was always false, so it meant that the lines never met. This time it's always true. So if it's always true, they always meet. Well, what does it mean if it's always meet? Well, if they always meet, that means they must be the same line. And if they're the same line, where do they meet? They meet everywhere. There's an infinite number of solutions. So when you end up solving a system, you're going to end up with either one specified ordered pair where those lines met, or they're going to be parallel and they never meet, or they're going to be the same line. So let me just prove to you that these are the same line. I won't graph them this time, but I will do other things that we have done in order to prove that. I'm going to rearrange the second one into y equals mx plus b more carefully this time because clearly I made a mistake before. And I didn't want to take time to try to fix it, but I want to get y by itself, so move my negative 8x over here, it becomes positive. I get 2y equals positive 8x minus 2. Then I divide everything by 2. Taking my time to do this now. Y equals 4x minus 1. Voila! Same exact equation. Where do they meet? They meet everywhere. How many solutions? Infinite solutions. There you go.